Hello, this is John Graham with Fluke Networks, and I will be your host on this short training video as we learn how to use the CopperPro to measure voice frequency metallic noise, power influence, and power harmonics. Noise on copper pairs can come from a variety of sources. One of the most common sources is power line interference noise due to the simple fact that telephone lines are very close to power lines. You can use the CopperPro to make several measurements that will allow you to determine whether or not a pair is suffering from power line interference noise problems. You can measure VF metallic noise. This is the noise that exists between tip and ring where the voice and modem signals are. You can measure power influence. This is the noise that exists between tip or ring reference to ground, and it has the capability of producing VF metallic noise. You can measure power harmonics. Power harmonics are measured and displayed on a power harmonics spectral graph, which graphically shows you the frequency content of power influence. This graph allows you to actually see the offending frequencies that have elevated the power influence level. Identification of the offending frequencies is a key part of the noise mitigation process, as it enables noise mitigation specialists to relate certain offending frequencies to the most likely cause. Things like poorly balanced power lines, open cable shields, defective capacitor banks, or defective step-down transformers. Okay, what I'm going to do now is show you how to use the CopperPro to analyze noise problems on a pair. I've got the CopperPro connected to a pair that's about 1,300 feet long. This pair has a tip ground problem, and this pair is also suffering from a high level of power influence. First thing I'm going to do is go into the POTS toolbox, and I'm going to scroll down to VF noise. I can check the settings of VF noise by hitting setups. You can change these if necessary, but I highly recommend that you just leave them in the factory default settings. If I do want to change one, I simply scroll down to the one I want to change. I would use the edit key to make the change. Now I can use up and down to flip between 900 or 600 ohms. However, I want to leave it at 600 ohms, so I'm going to abort those changes. I can make other changes as well, but again, I'd highly recommend you just leave it in the factory default setting state. To run the test, after we have it highlighted, we simply hit test. And you'll see in the top it displays the metallic noise and the power influence. The metallic noise is about 29.7. The power influence is about 79.4. We're also using a C-message filter to measure the noise, and we are terminated as far as our impedance goes. If I want to see the power influence measurements continuously, I would hit the continuous button, and you can see it's about 79.4. If I set the reference, then it will tell me how it changes over time. I could leave this on here for a few seconds or several minutes, and after the few seconds that I hit the reference key, you can see that it has reached a maximum of 79.5 and a minimum of about 79.3. I can also look at continuous metallic noise between tip and ring. That's about 30 or so right now. One of the things I want to stress in this video was the importance of having good balanced pairs. I already told you that I had a fault between tip and ground. I want to show you what happens when I take that fault off. If I remove it now, such that the pair is now balanced, look what happens to the metallic noise. It drops from 29 or 30 all the way down to 10. So you can see I have taken care of a noise problem by just making sure that the pair is balanced. Okay, I'm going to put the fault back on the tip side again, and you can see our noise goes back up. What is happening is that high power influence noise is actually translating into metallic noise due to the unbalance that was on the pair. I can also measure the continuous longitudinal balance, and you can see it's around 49.9. Okay, I'm going to back out now. I'm going to rerun the test. This time I'm going to take a look at the power harmonics by hitting the power harmonics button. The first time you run this, it gives you a static level of all the power harmonics. It has highlighted the highest one, which is harmonic number 9. You can see this crosshair identifies the one that it has measured, 9. It is a level of -17. It is harmonic 9, and the frequency is 540 hertz. I can move over to the next one, to the left, which is harmonic number 7. It has a level of -20, and it's 420 hertz. I can also move to the right and look at other harmonics. I had mentioned earlier that certain kinds of problems will produce higher energy in certain harmonics. If you have that information, then this will help you pinpoint what type of noise is getting onto the pair. If I want to run the harmonics continuously, I'd hit the continuous button. And now it gives me a continuous reading in real time of the power harmonic levels. Okay, I'm going to back out now. And that concludes our brief video of how to use the VF noise measurement tools on the CopperPro.